Hi guys, Mrs. Sugi here. This video is going to cover section 9.2 where we revisit the parabola. Although we've graphed parabolas before, they are in this section because parabolas belong to a group of graphs called conic sections. And although there is some extra information about them as related to conics, it won't change how we are going to graph them. So first we're going to review graphing parabolas, and we're just going to do it like we have already learned how to do it. And then on the back side, we are going to go deeper into questions related to parabolas and quadratics, although we probably aren't going to take all of this back to conics in general. So let's start with just a basic review. Parabolas, the parent function is just f of x equals x squared or y equals x squared, and they're the ones that have a vertex at 0, 0. And then we have this graphing pattern of 1, 3, 5, 7, 9, etc., right? And those are what I always refer to as the up increments. And this is the parent function with all of the other information added onto it. So HK represents our new vertex, as in where the vertex is going to get to. And then the A value alters any kind of graphing pattern, right? We take whatever is in that A position and we times it by the 1, 3, 5. Okay, and I know we have done this before, so I won't try to take too much time. So the 3 and the 5 are in the HK position, and wow, what we had done before is just say that that we always take opposite the sign in the H position. So if it says -3, it plots as +3. But the K position actually goes with the sign. All right, so if that says -5, we really are going to plot -5, -5. Okay, so 3, -5 is what gets put on our paper first. And then we do our graphing pattern. From the vertex, we go over 1, up 1, over 1, up 1, 2, 3. And if you have space, over 1, up 5. All right, and try to make it U-like. It's not a V. All right, and I knew it was a 1, 3, 5 pattern because there was no number in the front here, or the number in the front is actually just a 1. So that means we have our 1, 3, 5 pattern. Okay, so over here, our H and K take us to our new vertex, -4, 6. All right, and let's see, so -4, +6 is up here. And now we have a -2 in that A position. So what that means is we take our graphing pattern of 1, 3, 5, ... because it continues on, and we multiply it by the -2. So this is our new graphing pattern, and these are the ups, or in this case, because they're negative, they're going to go down. So it's always over 1 from the vertex and then down 2. All right, and then from those points, over 1, down 6, 4, 5, 6. All right, and we don't have enough to fit the other one on. All right, so just an observation that having a negative made my parabola flip upside down, and having a number that is like a bigger than 1, or I guess less than -1, right? That's not a proper fraction, made it narrower. All right, next step with parabolas is we can see it's a parabola because it's x squared, but it's not in vertex form. So these are the ones we had to convert to vertex form. So where there are definitely some steps involved in here. What we had to do is group off the x terms, x squared minus 4x, and then we leave a gap. We write the -1 on the outside, and in that gap we had to do something called completing the square. So the way that worked is we would take half of this middle term, so that would be -2, and then square that, and that's the number that you place in there. And it always goes positive no matter what, so you can always just automatically put a plus, because it will, no matter what, be positive. So now I've just altered the value on the right-hand side of this equation, and so I want to account for that. I don't want to mess up my equality. right? That's what this equal sign means, is that these two sides were balanced. All right, so if I add 4 here, then I have to subtract 4 on the outside of my equation. All right, so I've basically added a net value of 0 on the same side of the equation. All right, and I do that because I want to keep it solved for y, because normally if you add 4 on one side, then you could add it on the other, but you don't want to have a plus 4 over on the side that the y is on. Okay, so if you have completed the square correctly, right, then you should be able to factor this into 2 identical binomials, and the whole purpose of that is that you can write it as a perfect square, right? And then minus 1 minus 4, that's where that minus 5 came from. All right, so here's our new equation, right? Our vertex is positive 2, negative 5. All right, and we have a graphing pattern of 1, 3, 5. We didn't generate any number in the front there, so our pattern is 1, 3, 5. Okay, number 4. This one's more complicated. So when you partition off the x terms here, there's actually a 2 in front of this x squared term. And so we have to deal with that first by factoring it out only from the x parts. So it's going to become x squared plus 6x. Leave that blank. To complete the square. Don't alter the plus 16. That's going to stay plus 16. All right, now there's a bit of a glare there. And then we have to account for what we put here on the outside. So now we're going to follow our little rule. Half of 6 is 3. 3 squared is 9. So we're going to add in a 9. But be careful, don't automatically do minus 9 on this one. So if you remember, we added a 9 into a set of parentheses that was being times by 2. So our true value here is 18. That's really what we have added right here. So on the outside, what we need to account for is not minus 9, but minus 18. All right, so now that 2 is going to be in that A position. Let's see, what have we got here? This will factor into x plus 3 times x plus 3. So I'll go ahead and write it as x plus 3 squared. And 16 minus 18 is a minus 2. All right, so our vertex comes from, and that number in the front doesn't affect how you get your HK, your vertex. So we have a negative 3, negative 2. All right, and our graphing pattern is going to be 2 times 1, 3, 5, etc. So that's going to be a 2, 6, 10. Negative 3, negative 2. So we're going to go 2. And then from those points up to 6. All right. Numbers 5 and 6. All right, so 5. 5 is not terribly hard to graph. It's just sometimes when you're missing a letter, it just seems more confusing. So if we line it up with the generic form, right, the HK form, x minus h squared plus k, the number that is missing is the h. All right, and then the k is in the 5 position, or the 5 is in the k position, and the negative 3 is in the a position. So the vertex here is 0 for the h, 5 for the k. All right, and then our graphing pattern is going to be negative 3 times that 1, 3, 5. So negative 3, negative 9, negative 15. Let's see. So there's, all right, and this has made it much narrower, if you can see. So proper fractions make it open wider. Narrow, improper fractions or whole numbers make it open narrower. All right, and then last one. So again, it's a parabola. It's not in the graphing form. So the tricky thing about this is, so we're going to follow our rule. We only partition off the x terms. So when you factor out a 1/2, right, this does not go down to a 3. That would go to a 3 if you were factoring out a 2. When you're factoring out a 1/2, it actually goes in just the opposite direction. So I always just think you could try to think about dividing out a 1/2 from the 6. Or I just think in terms of the fact that if I were going to distribute a 1/2 back through here, I would need a 12 here, and that would generate the 6 that's already there. All right, and then we have the gap for the number we add in, and then the plus 15 we don't touch. All right, and then we have our other gap for the number that we have to subtract or cancel with. All right, so let's see. Half of 12 is 6. 6 squared is 36. I'm going to put that in red. Always plus. Okay. So this is a true value of 1/2 times 36, which is 18. Oh, another 18. Same as the one above, but for different reasons, huh? All right, so if you add 18 here, then you're going to have to account for that by subtracting it on the outside. Okay, so now we have y equals 1/2 x plus 6, right? 6 squared, and then this is going to be minus 3. All right, so our vertex is -6, -3, and our counting pattern is 1/2 times 1, 3, 5. So I would go mixed fraction for these because it's easier to count on a grid with mixed fractions. So it's 1/2, 1.5, 2.5. Okay, so -6, -3, 1, 2, 3. All right, so from here we're going to go over 1, up 1/2. And now when we go from here over 1, up 1.5, you should be able to get back to exact points, right? So sometimes people just give up on trying to ever hit exact points and decide they're just going to sketch a parabola anywhere on there. I will check, right, for you guys hitting some of those exact points. And then the next set is going to be in between 1, 2.5. So that would be winner. Okay, on the back side, we are just going to answer some questions that, you know, are related to parabolas and graphing, but not quite so nuts and bolts of just graph it. So number 7 asks, what is the minimum value of this function right here? So my first observation is that it is a parabola. All right, so when you think about a parabola, wherever it is on your XY grid, this one's going up since there's no negative in the front. Right? The minimum value is going to be the lowest point on your graph, which will be where the vertex is. But more specifically, let me sketch a XY on there somewhere. The minimum is a question about asking how low has it gone. So really what we want to figure out is what's the Y value of the vertex. All right, so in order to get that, we need to be able to get a vertex. In order to get a vertex, we're going to go through those steps that we've already practiced on the front where we have to complete the square. So we'll partition off the x squared. So again, I mean, this isn't hard by now since we've already done it a few times on the front. It's just, do you know actually how to answer the question? Okay, so we are going to add half of 14 is 7. 7 squared is 49. All right, then we account for that by doing a minus 49. All right, let's see, 49 and 36 is what? 13 minus 13. All right, so we know that our vertex is at positive 7, negative 13. All right, but that's not really the final answer, right? The final answer is just the y value. All right, our minimum is at negative 13. All right, number 8 gives us a picture to look at. I mean, and again, none of these are too hard to figure out, but just trying to figure out, I guess, what you're supposed to answer, like what is it asking? So we're going to refer to the graph. It asks for what values of x is each statement true. So for what values of x is f of x equal to 0? So I'm going to, in my mind, replace the f of x with a y, and then, re-say it. For what values of x is y equal to 0? So I'm just going to look on my graph and figure out wherever y is equal to 0, what's the x that goes with it? All right, and when y is equal to 0, that's these points right here. All right, that's basically, it's asking what are the x-intercepts, what are the roots, just asking it in this way. Let's see, that's a 1. I know the grid is pretty faint, but okay, so the y values are 0 when x is negative 5 and positive 1. My answer to the question is x is negative 5 and positive 1. All right, for what values of x is f of x less than 0? So for what values of x are the y values less than 0? All right, so like when I think about y values, I'm just going to trace on my little red line here. Y values are negative starting like at, say, negative 5 or negative or 1, whichever one you want to start at, but the y values are all negative from here to here, right? My y values are negative in this span of x values from negative 5 to positive 1. All right, so I'm going to answer it using the between notation, as in, I'm going to cover that one up. The x values, they have to be less than 1, right? That's starting here, but they have to also be greater than negative 5. And so the way I write that is I use a less than symbol because the x value is on the, kind of backwards now, but this is still saying that x is greater than negative 5. All right, so together that just means that x has to be between negative 5 and positive 1. Okay, for what values of x is y a minimum? I'm just going to, y is minimum for x equal to, all right? So the minimum value we talked about above is the lowest point on your graph, which is here. This location is negative 2, negative 3. All right, so am I supposed to answer the x or the y value, right? So y is a minimum for x equal to negative 2. Okay. All right, number 9 gives us a picture, and it just asks us to write an equation for the graph. So it's a parabola. It just makes sense, we would start with the vertex form. And so I need the vertex and I need the a value if there is one. So the vertex right here is negative 2, positive 1. Those lines are faint, hard to read, but negative 2, positive 1. Right, so that is the h and the k. And then the a value I should get by, usually the first increment that you look for is the telling one. So this looks like it's gone over 1 up 2 on either side, right? That value is 2. So that's whatever that first jump is what your a value should be. You should be able to read it off your grid, even if there's not any dots there, like this one has the actual dots on it. Okay. And let's see. So I'm just going to replace that information. I'm going to put 2 for the a x minus negative 2, so that's going to go plus 2 squared, and then plus 1. All right, and number 10 asks us to solve the system of equations for x, y. Okay, so system of equations. So we've got two together, and what that means visually, even though I don't think we're going to do it with graphing, is that we're trying to find out where they intersect each other and give that answer. That's a parabola parent function, right? There's no shifts or anything different about it. And then this is just a line. And so, I mean, I guess I'm assuming that they are going to intersect, but it is possible that if your line were down here, then they wouldn't officially intersect. But I mean, that's going to have a y-intercept of 24, and it's going to have a slope of 2. So I don't know. I mean, I'm sure I'm not doing it very accurately, but I would expect it to have two solutions. So that's what we're trying to find. Where are those two going to connect or intersect? And I mean, we could graph it, but this is intended for us to do with algebra. So I'm going to use the substitution method, as in if y is equal to x squared, I can sub it into this second equation. And now I have one equation. It only has x's, so I can solve it. And what is new for us is when we've done stuff like this before, we haven't had to deal with a quadratic, but now we do. So I'm going to go ahead and subtract the 2x over to the left, subtract the 24 to the left, get it set equal to 0, so I can try to factor and use the zero product property. And if it's not factorable, I have to use a different way to solve it, but this one looks like it's going to go, because I think a 6 and a 4 combo would work to give us a negative 2 in the middle. So minus 6 plus 4. So 6 is one of our answers. All right, and then a lot of times with quadratics, we always just leave it here. But remember, the big picture on this one is we're looking for these 2 points of intersection, right? So we want to be giving full coordinates. Like this would be the negative 4, this would be the 6, but they are each combined with some y value. So to get that, we're just going to plug the 6 into for the x in either one of these two equations. I mean, the parabola one is a little bit shorter, right? We can just plug a 6 in there, square it, so we get a 36. And a 16. All right, so final answer here is when x is 6, y is 36. All right, and when x is negative 4, y is 16. So we actually have two solutions for this. And I mean, here's my little sketch. It kind of, lines up. It's believable. Sometimes my sketches aren't. All right, good luck to you. And well, I definitely didn't hit everything on the worksheet, but as you can see, I mean, everything's geared towards parabolas, quadratics. I'm pretty sure everything on this assignment you have seen before in one way or